In this video, we're going to be analyzing the results from our Releasing the Energy in Food lab, where we burned the 3 different foods. So we have the data table here with all of the calculations done for the cheddar popcorn, the saltine crackers, and the peanuts. And you can see that the cheddar popcorn came out with about 0.27 kilocalories of energy in that actual sample. So this is compared to the mass of our sample. The saltine crackers had 0.13 kilocalories of energy, and the peanuts had 0.7. So if we rank them in order, the peanuts had the most energy, and the saltine crackers had the least amount of energy in them. So now we're going to compare each of those foods to the actual carbohydrates in the fats in a regular serving of them, just so we have some numbers to look at. We're also going to make some observations about what happened when we burned the foods. So if you think back to the popcorn and the saltine crackers, both of those foods burned quickly and they had a very tall flame. So it was a quick burn, but it was an impressive flame. It went up very high compared to the peanuts that burned very slowly and had kind of a low, steady flame. These are the observations from the video, the first video in the series in which we actually burned the foods and collected the data. So in this lab, we've measured the amount of energy released from these foods, but let's talk about carbohydrates and lipids themselves. What do we get from carbohydrates? Carbohydrates give us quick, usable energy. It's energy that's used right away in our bodies. And lipids give us a long-term type of energy. So it's something that lasts a long time. So I want you to take a look at how the foods burned over here and look at what carbs actually do for us and what lipids do for us, and see if you can make any connections there. From this, you should be able to make the connection that carbohydrates, which are pretty much what the popcorn and the saltine crackers had a very large quantity of, particularly the saltines, they burned quickly, just like carbohydrates give us a quick form of energy. The peanuts, for example, they burned very slowly and had a low, steady flame, and they are very high in lipids. Fats are lipids, and these are a long-term version of energy. So basically, the flame and the characteristics of the food actually burning are a great representation of what happens when we actually digest this food in our bodies. Carbohydrates give us a very quick burst of energy. Think about eating a lot of candy and how much energy you get immediately from eating that candy, but it doesn't last very long. Just like the fire, the flame, when we burned those foods. They burned very quickly. It was a tall flame. It was a quick burst of fire, but then it fizzled out very quickly. Compared to lipids, they give us long-term energy, just like the peanuts burned for a really long time, and they had a very stable flame. That equates directly to the amount of energy that we get from lipids. So one of the big connections to make in this lab is this. The tall, fast flame from burning carbohydrates is similar to the quick burst of energy we get when we eat carbs. Lipids burned slowly but released more heat because they had more energy stored in them. Lipids actually have 2 times more energy available than carbohydrates, but our bodies choose carbohydrates because they are easier to use. And that's the next thing that we're going to talk about. How does the actual structure of a carbohydrate and a lipid go along with this amount of energy that each of those gives us. So when you look at the structure of a carbohydrate, carbohydrates are a polymer that is made of a bunch of glucose molecules joined together, kind of like beads on a string. Lipids are not a polymer, they're just a really big giant molecule. So they're more like a big blob of a molecule. Because a carbohydrate is a polymer, these bonds right here are really easy to break. And as a result of it, there's less energy in a carbohydrate for your body. They release less energy. The bonds in the lipid are much harder to break because they're a bigger molecule. They're actually made of many, many more parts. They have more bonds in them, but they're just not as easy to break as the carbohydrate monomer, the bonds between the monomers of the carbohydrate. So therefore, lipids actually have more energy to release because of the structure of those molecules. Okay, so when you think about this lab, I want you to think about the fact that these molecules have different types of energy in them. We get different energy from carbohydrates than we do lipids. Carbohydrates, just like the fire we saw when we burned carbohydrate heavy foods like popcorn and crackers, it was a quick surge of energy, but it fizzled out very quickly, and it did not heat up the water very much. It did not release a lot of energy. Whereas the lipids had a low, slow burn that lasted quite some time, and it really heated up the water because they had so much more energy to release as a result of their structure and all those bonds that are very difficult to break.